Hello and good afternoon, CSI257 students for the fall 2014 semester at Anne Arundel Community College. And this is the third of 4 Cisco Networking Academy courses. It's the Scaling Networks course, and today's PacketTracer tutorial is going to be the Skills Integration Challenge, which is PacketTracer 3.3.1.2. And these are some of the funnest packet tracers to do because we've got a full topology here, and we're really going to pull together everything that we've worked on to date in this class, actually, for the first 3 courses. And we've got some VLAN creation, some EtherChannel creation, spanning tree. So obviously focusing on the topics for this course, but drawing from the 157 and 158 course. So let me make sure that my font is large enough here. So yeah, we've got a 16 font, so we're good there. It should be easy to see, and we'll go ahead and close that down. So as you can see, we've got quite a bit of activity here in the topology. We've got 4 switches that sort of make up our layer 2 core, going out to 2 routers that are then interconnected, and then they both have connectivity out to the internet. Typically, you're going to want to start with your layer 2 tasks first, because if we're doing some layer 3 work here, it might not function correctly without that layer 2 work done. So I'm actually going to go ahead and start down here at the bottom and then finish the layer 2 tasks, and then we'll work our way up to the layer 3 tasks. And I think you'll find that that's a pretty solid approach here to make sure that we've established that layer 2 connectivity right out of the gate, and then it'll allow us to focus on the layer 3 connectivity. So right away down here, we're going to take a look at the spanning tree tasks, because this is some low-hanging fruit for us here. So the first says configure per VLAN rapid spanning tree mode for all switches. All right, so let's go ahead and pull up switch 1, and we're going to get all 4 switches up here, and then switch 2, try to make them the same size, and then switch 3, whoops, and finally we're going to pull up switch 4. And as you can see, there's definitely going to be some EtherChannel work in there as well. So this is a pretty nice exciting tutorial skills integration challenge. All right, so I'm on switch 1 and we're in user exec mode, so we'll transition to privilege exec and then on to global config. And so the per VLAN rapid spanning tree mode for all switches, right? And the spanning tree priorities are listed there below as well. And you can see there's going to be some VLAN creation for at least VLAN 10 and VLAN 20. And so we'll sort that out here in a second. So first let's go into spanning tree mode. And if I do the question mark, you can see we've got the PVST, which is the per VLAN spanning tree mode. And then we have the rapid PVST. And so we've been asked to configure per VLAN rapid spanning tree for all of the switches. So this is going to be rapid PVST, and in fact I can actually copy this, and we're going to jump over to switch 2, and again from user exec to privilege exec into global config, where we will paste in spanning tree mode rapid PVST. We'll come to switch 3 and go from user exec to privilege exec to global config. We'll paste that one in there, and then finally on switch 4, user exec to privilege exec to global config, and then we've now converted all 4 switches over to rapid per VLAN spanning tree. And as you can see, we did all 4 switches. We've got 4 points. So this is clearly some of the low-hanging fruit here. 1 point per per task there on the per VLAN rapid spanning tree mode. So then it says configure spanning tree priorities according to the table below. And so we're on switch 4. We're going to hop over to switch 1 here. So we're going to set spanning tree, VLAN 10 priority to 4096, making it the root for VLAN 10, the root bridge for VLAN 10. And then we're going to set the spanning tree VLAN 20 priority to 8192, probably making it the backup, right? Because switch 2 will be the primary or the root bridge. Sorry about that. And we got priority 8192. And that's on switch 1. So now we'll jump over to switch 2. And we're going to say spanning tree VLAN 10 priority. And that's going to be 8192. And then spanning tree VLAN 20, and it'll be the primary root bridge at 4096. 4096. All right. Switch 3 and switch 4. And it's interesting here, when you're looking at the drawing, you can actually sort of take a look at this drawing and say, here is our access layer, right? We talk about network design. So here's our access layer. Okay, so this would be our access. And you could think of this as your distribution layer, right? Or the distribution layer. Okay, and then here is our core with our routers in the core. Now, typically in the distribution layer, these are going to be multi-layer switches, right? And these could be multi-layer switches here, but typically, right, typically you don't have routed access. It's very possible, and I've seen it before, but in most cases, you're going to see sort of a layer 2, right? So your layer 2, layer 3 boundary is right here. So this would be where you've got your layer 3 distro, and these guys right now in our lab, these are just layer 2, but typically that's your boundary there. So you've got your layer 2 down here, and then you start your layer 3 up here, and then you've got your core, which takes you out to the internet, or it could take you over to another data center of some kind, right, to their core. So again, access and distro, and that's why the 4096, the spanning tree priority is 4096 for VLAN 10 here, and then it's 4096 for VLAN 20 over here. So these guys are going to be your primary and secondary root bridges for, it looks like, all VLANs in our topology. I only see VLAN 10 and 20 that are in there, right? And so that's typically what you do, is you'll typically see that the distro layer, or if it's a collapse core, that is where you will have your primary and secondary root bridge. So let me go ahead and clear the screen there and go over to the cursor, and let's do a quick check here. I want to see, so it should be VLAN 10 and 20. So there's a VLAN 99, which is our management, the native VLAN, so it looks like just 10 and 20. Okay, so we're good. All right, so we've done that. So now switch 3, right? So it's the access layer switch, so we don't want an access layer switch being the root or the secondary if possible. So we're simply going to set it to 32768, which is probably the default, but we're going to hard code that anyway. My guess is, since we only have 8 points over here, is that they don't want us to leave it at the default. They want to see this hard coded in there, and we'll find out right now. So spanning tree VLAN 10 priority 32768, which is the default. Let's see if it goes from 8 to 9 points. So it was definitely looking for that. And same thing with VLAN 20, right, on switch 3. And now let's jump over to switch 4, and we're going to run those same commands. So spanning tree VLAN 10 priority 32768, and then spanning tree VLAN 20 priority 32768. And again, you can see we're being given points for that. Even though 32768 is the default, PacketTracer is definitely expecting and anticipating we enter those commands in. All right, so we have just set up all of our spanning tree tasks here, right? We've got, this is all knocked out right now. So let's take a step up here and take a look at the ether channels, And actually before that, let's come back up here to the VLANs. This might have been a better place to start, but spanning tree was quick and easy. So let's knock our VLANs out here. So for all switches, create VLANs 10, 20, and 99. And so here's a great opportunity. And you've seen we've got the VLAN 10, VLAN 20, VLAN 99. We'll type in and then write mem, right? So we'll save our config. And so I'm going to go ahead and drop this. Let's make sure. So for all switches, right? So we'll start at switch 1, and we'll paste that in there. And it saved our configuration. We'll go to switch 2. We're going to paste that information in there, right? And go to switch 3. We'll paste that information in there. And again, the reason I put it in Notepad is because we can recall it quickly. And then all we need to do is cut and paste. And then paste, and there we go. All right, so we have created, and I actually should have had it do a show VLAN brief to make sure that they're in there, but they're in there. All right, so configure the following static ports for switch 1 and switch 2. So FA01 through 09 are going to be access ports in VLAN 10, and then 10 through 19 will be access ports in VLAN 20, and then 20 through 24 and GIG01 to 1-2 as the native trunk for VLAN 99. Now let's take a look at what we've got here. So 23 and 24 are running between these two guys, and 21, 22. So I'm sorry, for switch 1 and switch 2. So 23, 24 here. So we're good there. And GIG01 and GIG02 are going to run down to switches 3 and 4 respectively off 1 and 2. So again, not a bad idea to leverage Notepad here. And so, whoops, bring that back, and we'll come down here to the bottom. So it wants to configure the following static ports for switch 1 and switch 2. So we would do interface range FA 0/1 to 0/9, and we're going to say switch port mode access, and then switch port access VLAN 10. Whoops, VLAN 10. And we're also going to go ahead and we're going to say spanning tree port fast. And I'm going to say spanning tree BPDU guard enable. So we're going to put those on there because if those are access ports, we would definitely want to have those settings on there. And so let's go ahead and take a peek here and make sure that this code is going to work here. And I'm on switch 1, so we want to be in global config when we drop this in. And I have a typo there. It's going to be spanning tree, port fast altogether. It had the dash in the wrong location. So spanning tree port fast BPDU guard enable. So we're still in that interface range, so I would come back over here and say interface range FA 0/10 to 19, right? And so we're going to run pretty much the same thing. So I'm going to cut and paste this here, copy, and we'll hit enter, and we'll paste it down again. And it'll just simply be 10 to 19, and these guys are going to be VLAN 20, and we're going to do port fast and BPDU guard on there. So I'll say copy, and we'll exit out here. All right, perfect. Okay, so those ports are all set up. So now that we have it in Notepad, it's going to be very easy for me to come over here, cut and paste all of this, and simply drop it onto switch 2. And let's make sure we've got one more section here. So let me paste this down in here, and this is going to be FA0 or FA 0/20 to 24, and then GI 01 to 2. And we are going to make those trunk ports, switch port mode trunk. So we do not want to have these commands. And switch port trunk, and I can never remember if it's native or VLAN native first, so we'll check that out. So we've got, let me copy this and drop it here. All right, and then we're going to go, whoops, so we had switch port trunk. I think it's native, yeah, native VLAN. And the native VLAN is going to be 99. So switch port trunk native VLAN 99. All right, so right here we've got all the commands we need for switches 1 and 2. So now I can just grab this like this. Ah, I forgot something. So no shut. I should have done no shut in there. And then we'll come down here, and these guys are going to come up automatically, but I am going to go ahead and put a no shut in there, and then end, and then a write mem to save my config. All right, so those guys have been dropped in there. No shut, end, write mem. Okay, so we're going to grab this. Plus, we know we're getting the same config on switch 2. So we don't forget to type something in. And we'll go into global config mode. So you can see there we are receiving our native VLAN mismatch error, as you would expect. And now let's paste all of our config information in there. And that was pretty quick. Look at that. And it saved our configuration for us. Okay, so we're going to be doing something very similar on switch 3 and switch 4. So let's take a look. So for switch 3 and 4, we're going to do the same port ranges. Those port ranges are in the same VLANs, 10 and 20, and then the trunking interfaces are actually 21, according to the instructions there, 21 to 24, and gig 01 and gig 02. All right, so let's go ahead and see if we can copy all of this and come over to switch 3. And you can see we've got native VLAN mismatch, and so we'll go into global config, and all done, and the consistency has been restored because the native VLANs are the same. Oops, we'll go into global config. It'd be a mess if I did not go into global config. All right, so we are looking very, very good right now. Let me check switch 4. It's funny, it wanted 21. Okay, here it is. All right, so 21, 22, 23, 24. And these guys were 21. So it started at 20. So for some reason, it had us take on switch 1 and 2. We started at 20 and went to 24, although I don't see 20. I see 21, 22, 23, 24. And that's okay. We're going to go ahead and leave that the way it is. All right, so the VLAN setup is now complete. Okay? All right, so the Ether channels. So all Ether channels are configured as LACP or LACP. All Ether channels are statically configured as the native trunk for VLAN 99. So we're going to set up all the Ether channels as trunks. So use the following table to configure the appropriate switch ports to form Ether channels. Excuse me. So the first port channel will be between switch 1 and switch 3, switch 2 and switch 4. And so this is really where we've got the bulk of the work. And so we're going to go ahead and pull switch 1 up here and get started. So remember from the previous video, we're going to say interface range GI01 to 2. We're going to shut these ports down, and we're going to say switch port mode trunk, and then we're going to say, oops, channel group, and it's looking for channel group 1 or port channel group 1 mode. And remember, we're doing LACP. So they're going to be statically configured, and we're going to go, it's either passive or active, but we are going to use active on all of these to make sure that they are all trying to negotiate an LACP Ether channel. So channel group 1 mode active, and so then at this point I'm going to go ahead and say no shut, int PO1 no shut, and bring that interface up. And now I'm going to go over to switch 3, and we're going to say global config mode interface range GI 0/1 to 2, and that's correct on switch 3. So we're going to shut these guys down. We're going to say switch port mode trunk, And then we are also going to say channel group 1, and the mode is going to be active. And I'm going to go ahead and actually I need to go back over to switch 1 really quick, and let's jump into interface PO1, and we're going to say, whoops, switch port mode trunk, right? And this interface is up. So if I do a do show interface trunk, would we see it? We're not going to see it yet, right? Because it has not negotiated as a trunk yet. So we don't see that interface in here. So let's jump back to switch 3. You can see we have port channel 1, and that's the one that we're working on. So interface PO1, and actually before I do that, we'll bring those interfaces up. Int PO1, and I'll say no shut, even though it looks like it came up there. So now if I do a do show EtherChannel summary, you can see we've got gig 01 and 02. They're in the port channel, and we are a layer 2 port channel in use, right? So we're good here. Let's take a look at switch 1. What does switch 1 see? Do show EtherChannel summary, and sure enough, switch 1 sees the exact same thing. So there's our first port channel. So now we're going to jump over to switch number 2. So go to global config from privilege exec, interface range GI 01 to 2, and we're going to say shut down. We're also going to say switch port mode trunk, and then whoops, channel group, and this is going to be channel group 2 mode active, and we'll bring those guys up. So then we'll say no shut, and then int PO1 switch port mode trunk, and no shut. All right, so he should be up on switch 2. Now we need to jump over to switch 4. So again, from privilege exec to global config, interface range GI 0/1 to 2, and you can obviously see you're going to get a workout here on configuring ether channels. Interface range gig 01 to 02, so we'll shut these guys down, and we'll say switch port mode trunk, channel group 2 mode active, and we'll go ahead and bring these guys up. So we'll say no shut, and then we'll say int PO1 switch port mode trunk, and no shut, even though it looks like it popped up already. So we're going to enter those commands anyway just to be sure, right? So now if I do a do show EtherChannel summary, all right, so we've got port channel 2 is up. It looks like there's a port channel 1 here. I have to check that out. So port channel 2 is here, and LACP, and the ports are in there, and this is between switch 2 and switch 4. And I'm hoping do show EtherChannel summary. Did I may have ran the commands on the wrong switch, but we'll see in a second here. So switch 2 and switch 4, so we're good. EtherChannel 2, and there's switch 2 and switch 4 with the LACP EtherChannel. All right, so EtherChannel number 3 is between switch 1 and switch 2. So we'll say interface range FA 0/23 to 24, and again switch port mode trunk, and it's looking for all EtherChannel statically configured using native trunk for VLAN 99. So I need to make sure that we're using the native VLAN as well. So we may be missing some points there. So I'll have to step back into those port channel interfaces and configure that. So we just shut down the interfaces, switch port mode trunk. Did we shut these guys down yet? There we go. And then channel group. And this is going to be channel group 3 mode active. All right, so now I'm going to say no shut, int PO3 switch port mode trunk, and then switch port trunk native VLAN 99. So we should see some errors between the two sides here, and it should be set, but I want to set it on the port channel anyway. All right, so that's on the switch 1 side for port channel 3. So do show EtherChannel summary. So you can see we have port channel 1 and port channel 3. This is the one we just configured, right? And so it says I. So we haven't done the other side, so it says standalone, okay, which means these are standalone interfaces. They are not participating in the port channel right now because we need to go do the other side. So this is going to be switch 2's FA23 and 24. So int range FA023 to 24. We'll shut these guys down right now. Switch port mode trunk. And we're going to say channel group 3 mode active. So now we have that interface. I'll say no shut int PO3 switch port mode trunk, and then switch port trunk native VLAN 99, and then no shut, and the consistency has been restored. So now if I do a do show ether channel summary, all right, this ether channel is now up and operational on switch 2. And so this is between switch 1 and switch 2. Let's see what switch 1 now sees. Do show ether channel summary. And now they are in the bundle, right? With that capital P, they're in the port channel. Okay, so that was the third ether channel. The fourth ether channel is between switches 3 and 4. So we'll say int range FA0/23 to 24. We'll shut them down first, so we'll say switch port mode trunk, and then we're going to say channel group, and this is going to be 4, and mode active. All right, so then we'll say no shut. We'll go into int PO4, and we'll say switch port mode trunk on the port channel interface. We're going to say switch port trunk native VLAN 99, and we're going to say no shut. All right, so if I do a do show ether channel summary now, you can see we have port channel 4 here. But again, these guys are capital I, standalone, right? Because the other side of the ether channel has not yet been configured. And so this is going to be switch number 4. So we'll pull up switch 4 here, and we're going to say interface range FA 0/23 to 24. We'll shut these guys down. Switch port mode trunk. Channel group 4 mode active. And then we're going to go ahead and say no shut and bring these guys up. Go into the port channel interface where we're going to go ahead and set, so it's inconsistent, right? We need to make sure we get the VLAN. So switch port mode trunk, the native VLAN configured. Switch port trunk native VLAN 99. And then we'll give it a quick no shut. And there our consistency has been restored. So do show ether channel summary on switch 4. And we're looking really good. All right, so switch 4 looks great. All right, on to the 5th ether channel. All right, so this is going to be FA021 and 22 going over to switch 4. All right. So int range FA0/21, 21-22, and we're going to say shut. So we'll shut those guys down. Switch port mode trunk, and then channel group. This is going to be group number 5 mode active, and as you can see, we've got a native VLAN mismatch. So now I'm going to say no shut. We're going to go into int PO5 and say switch port mode trunk, and then switch port trunk native VLAN 99, and then a no shut. All right, and so if I do a do show ether channel summary, we can see here that we've got 1, 3, and 5. So on 5, these guys are capital I. They're standalone, right? You can see right up here, because they are not in an active bundle. They're not in an active port channel right now. And so they are at I, they are standalone. So let's go to the other side. And so this is going to be switch number 4, 21 and 22. So I'll say interface range FA0/21-22. We'll shut these guys down initially to do some work. So we'll say switch port mode trunk. And then we're going to say channel group, whoops, GROUP, channel group, and this is 5. Mode active. So we've got that set, and then we'll say no shut. We'll go into the port channel interface because we still have this inconsistency, right? We need to make sure the native VLAN is VLAN 99. So switch port mode trunk, switch port trunk native VLAN 99. A quick no shut there. So our consistency has been restored. So do show EtherChannel summary, and we're looking really good. And I'm going to go back and take a look at why we've got this guy here. I got to figure out why he's in there. All right, so we're good here on port channel 5. The final port channel is between switch 2 and switch 3. So we're going to say interface range FA0/21 to 22, and those are the physical underlay interfaces that we're going to be using. So we'll shut these guys down. Switch port mode trunk, and then channel group, and this is going to be channel group 6 mode active. So I'll say no shut, and then we'll go into port channel 6 and say switch port mode trunk, switch port trunk VLAN or native VLAN 99, and we'll give it a no shut. And then if I do a do show EtherChannel summary, you should see we've got the port channels here, and again, these guys are standalone here because the other side's not configured yet. So this is switch 2. Now we're going to step over to switch 3. All right, so interface range FA0/21 to 22. We'll shut them down so we can run our command. Switch port mode trunk, and then channel group, create our port channel here, channel group 6 and mode active. All right, so then we'll say no shut. We'll go into port channel 6, switch port mode trunk, switch port trunk native VLAN 99. No shut to be sure. Consistency's been restored. So we do a do show EtherChannel summary, and it looks really good. So these guys are all up, they're all operational. So switch 3 looks good. Switch 4 is with the mismatch, and I think that is on. Let's come over to switch 1. If I do a do show run, and we're going to take a look at the port channel interfaces here. Whoops. All right, so as you can see on port channel 1, we left off the native VLAN. So let's go into interface port channel 1 and do a switch port trunk native VLAN 99. And I think it might have been over on switch, is it switch 3, do show run. We'll come down here to the port channels, and sure enough we did miss that. That was right out of the gate. That was the very first one we did. So int PO1 switch port trunk native VLAN 99. So that should solve the inconsistency between switch 1 and switch 3. So do show EtherChannel. Whoops. I want to see the summary. All right, so switch 3 has 3. Switch 2, do show EtherChannel summary. So we've got this port channel 1, which may have been created by mistake. So let me make sure. Port channel 1 is supposed to go between switch 1 and switch 3. So let's double check this. Yeah, we've got a native VLAN mismatch here on port channel 1. We're still seeing the error. So if I do a do show EtherChannel summary, 1 is gig 01 and gig 02. And let me check switch 3 here. Do show EtherChannel summary. So those are correct. Alright, so switch 2 should not have a port channel 1, and it does. So there's a native VLAN mismatch with switch 4 on ports gig 01 and gig 02. Let's take a look here. We'll cruise down and see. Yeah, so port channel 2, we missed out on that as well. So let's go in there and do switch port trunk native VLAN 99. And we are going to say no interface, and I can just say PO1. Whoops. No interface PO1. No interface, it's going to ask me to put the whole thing in. Port channel 1. All right. Do show EtherChannel summary. All right, so switch 2 should only be involved in port channels 2, 3, and 6. All right, and it is, so we look good here. So we're going to save our config off. Make sure you save your config early and often. Switch 1 should only be participating with port channels 1 and 3 and 5, and it is. And so we're going to go ahead and do a write mem on that one. Switch 3 should only be participating in port channel 1, 4, and 6. Do show EtherChannel summary 1, 4, and 6. So we're going to save off our config there. And then finally, we'll take a look at switch 4, who should not be seeing those messages anymore. Do show EtherChannel summary. Aha, so he has this. So we're going to say no interface port channel 1. So that, for some reason, I may have created, probably have to watch the video back to see how I got that in there. But definitely a typo. And switch 4 should only be participating in port channels 2 and 5, 4 and 5. 2, 4, and 5. I'm looking over to the right here to make sure that my numbers correspond over here. All right. So let's save our config off here. So all 4 switches have had all of their VLANs created, all the ether channels created, and all of our spanning tree work has been done. So now we can roll up this way, and it's at this point where we're going to take a look now, and we're still getting a native VLAN mismatch, port channel 2. It's possible that I changed it on switch 2, but not switch 4. Int PO 2 switch port trunk native VLAN 99. There we go. Okay. So we'll save that off. All right. So as you can see, excuse me, we have a number of ether channels running 3 per switch, right? So there was quite a bit of ether channel work here, right? That was really sort of the main portion of the skills integration challenge. So now that this has been configured, we're going to take a look here. It does not allow assigning point values less than 1. It's checking 154 items. Not all configurations are assigned a point value, so check results assessment to verify. So there are 154 things that we're responsible for here. So this is, I didn't see that initially, so this is a pretty big ask. All right. So Inter-VLAN routing. So on router 1 and router 2, enable and configure the sub-interfaces with the following requirement. So configure the appropriate .1Q encapsulation, configure VLAN 99 as the native VLAN, and configure the IP address for the sub-interface according to the addressing table. All right, so let's pull up router 1, and we're going to go to the CLI here. Let me make this a little larger. So we've got some sub interface, so we're doing a router on a stick, and it looks like show IP route. Let's see what we see here. So we definitely have some routes. We've learned to route via OSPF on the serial 001 interface, and we've got 2 connected routes with their corresponding local routes. All right, so this is router 1. So I'm looking up at router 1 to take a look at the interfaces, and let me pause here real quick. All right, so we're on router 1, and we're going to go ahead and do the sub interfaces. So let's go ahead and do global config mode. We're going to say interface G I0/0.1 for our first sub interface. So if you take a look at the commands, right, we've got the encapsulation command, the IP address command. So we're going to say, put the IP address on here first. So IP address is going to be 192.168.99.1. subnet mask /24. And configuring IP routing on a LAN sub-interface is only allowed if it already has an 802.10 or .1q trunk. So we need to get the encapsulation in there first. So encapsulation .1q, whoops. And the VLAN ID on this guy is VLAN 99. And that is the native VLAN, right? So now we can pull the IP address command up and it's going to take. So we'll say no shut, bring that interface up. So now we're going to go into gig 0/0.10 to create the second interface in cap.1q. Oops, apologize, keep forgetting the native, or the VLAN and then the native. So this is going to be VLAN 10. And if I say native, we're not making VLAN 10 the native VLAN. It should be VLAN 99. So we've already determined that. So now we're going to say IP address 192.168.10.1, and it's a /24 as well. And then finally, we're going to say int gi 0/0.20. So incap.1q. Oh, I can't apologize. And it's going to be for VLAN 20. And we're going to say IP address, whoops. IP address is going to be 192.168.20.1. All right. So we've got those sub interfaces configured, and do show run. Let me check to make sure. We're going to bring up the main interface here in a second. I want to check to make sure that the serial interfaces have the... Okay, good. So the serial interfaces are already configured. So now I'm going to say int gi 0/0 no shut, and it's going to bring up all of those interfaces. So now what we need to check, right? We just brought up this interface here on router 1. We now need to take a look here at switch 1's interface, because we know that this is going to have to be a trunk port, right? All right, so let's go look at switch 1 and which interface that is going to be. I'm trying to figure out here. Whoops. So switch 1. And that may be why with switch 1. Okay, so now it makes sense. So that has got to be port FA020, right? So when we initially did the VLAN configuration and configured the static ports here and set up FA020 on switch 1 and switch 2, they had an extra port when compared to switch 3 and switch 4. And this, and here's how we're going to check. I'm going to pull up switch 1. Oh, and yeah, there we go. All right, fantastic. So as you can see, we received a message here telling us that Fast Ethernet 0/20 just came up, because I don't see over here any indication in the instructions, and I don't see the switches listed there. I may be looking past it, but they don't specifically come out and tell you that this is going to be FA0/20, but we see here that it is, and we've already configured it, so these links are going to be green. So let's go ahead and step over to router 2. And we're going to walk through our router on a stick configuration, just like we did on router 1. All right, so we'll go from user exec to privilege exec into global config. And I'm going to say, and I better get the addressing table up here. We'll say interface gig 0/0.1. And this is going to be our native VLAN. So incap.1q 99, and that's the native VLAN. IP address 192.168.99.2. And then we're going to jump into gig 0/0.10. Encapsulation .1q, and it's going to be VLAN 10. And we'll say IP address 192.168.10.2. And then we're going to go into interface GI 0/0.20. and we're going to say incap.1q 20, and we'll assign the IP address. IP address 192.168.20.2 with a /24. And that should do it. I should now be able to go to interface gig 00 and say no shut and have all of those interfaces come up. Again, on switch 2, we should see a message telling us, and the link just went green, we should see a message now on switch 2 telling us that that link is live. And sure enough, there it is, which is exactly why, whoops, not that part, just this part right here. FA020, change its state to up. Okay, so pull switch 2 back up here. All right, so we've configured the appropriate .1q encapsulation. We've got our router on a stick set up for the Inter-VLAN routing using router 1 and router 2. And it says configure the IP address for the sub interface according to the addressing table. We've done that. So this is it. This is all we've got left, right, is our OSPF, open shortest path first, routing protocol setup. So we've got 12 points that are still out there. Let's check our results and make sure that we've got everything the way it should be so far. So you can see OSPF, we've got no points here. We haven't done anything. And OSPF, so there's 6 things here and 6 things here. So there's your 12 points. So we should be at 100%, and boy, 154 configuration tasks. All right, so we're great. So everything's looking good. So we're going to add 3 routes in, and we're going to passive interface 3 interfaces, right? So we're going to passive interface all of the sub interfaces, and we've got 3 routes that we're going to be doing on router 1 and router 2. So let's go ahead and jump to it. All right. So on router 1, we're going to exit out here. We're going to type in router OSPF with a process ID of 1. And it says advertise the network for each sub interface, right? So we're going to advertise the network for each sub interface. However, we are not going to advertise those updates southbound, right? And I'm going to talk about that here in a second. First, let me do the configuration on router 1, and then we're going to talk about why you want to do this and why this is a good decision here. So remember, again, we've got OSPF running, advertise the network for each sub interface. So we're going to say network, and it's going to be 192.168.1, and we'll say .255 area 0, right? And so then I'm going to do the same thing for network 10 and network 20. And as you see, we've got some points coming in there for doing that. And then we're going to do the passive interface, right, for gigabit 0/0.1 and the 0.10 and the 0.20. Okay, and so we racked up 6 points right there. So the reason that this is so important, specifically why we would run passive interface on the sub interfaces, right? So let's remember, switch 1 is not a multi-layer switch, or at least, actually I should confirm that. But the bottom line is we are not running OSPF, right? So OSPF here, we are not running OSPF on switch 1. So there's no need for me to use those sub interfaces to propagate or to try to, to negotiate and talk OSPF to this trunk port. So we're not running OSPF here. And it's the same thing over here on router 2. They're going to ask for the same thing. So OSPF, right, is not being run down here on switch 2. So switch 2 doesn't need to run OSPF. Therefore, we don't need to send those advertisements of the networks or try to send down the negotiation, the hello packets, right? We don't need to do that between router 2 and switch 1, right? So the hello packets don't need to come down here. I don't need switch 2 receiving multicast traffic, asking it, hey, do you want to participate in OSPF? Hey, do you want to participate in OSPF? We know that it's not doing that, right? So therefore, we're going to passive interface those three sub interfaces on both router 1, and we're going to do the same thing on router 2. Okay? So you'll notice that we did put in the networks, though, and we're advertising these networks out, and we're going to see why this is very important and why we're doing it between these two routers here in just a second. All right, so that's why the passive interface is so important. Now let me go ahead and go back to the mouse. Okay, so I'm going to go ahead and type do write mem. So if I type do show IP route, you can see that we've got quite a few connected routes in here with a local equivalent next to it, but we're only learning one route via OSPF right now, and that's the 209.165.22.160. So if I come up here and I look at the 209.165.22.160, it's the serial 001 interface from the ISP going to, where is the 209.165.22 router 2 and 209.165.22.190 on router 2, and then the 161 is here. All right, so we're only picking up one network from OSPF right now, and it's from the ISP router, the internet router, or the internet cloud that we have here. So let's go ahead and let's knock out router 2. And so I'm going to go ahead and type router OSPF 1, and we're going to say network 192.168.2.0. Let me make sure I've got that right. Or I'm sorry, .99. 99.0. And we'll put the wildcard mask as a /24. Put that in area 0. We'll advertise out network 10, 192.168.10. And we're going to advertise out 192.168.20. Okay. And then finally we have our passive interface commands, GI0/0.1, 0.10, and 0.20. And that should take us to 100% on this PacketTracer activity. But if I do a do show IP route, I want to see, yeah, so we're only learning the one route via OSPF, and that's coming from the internet links. The connection, let me make sure that's right. So the connection between router 1 and router 2, which interface is that right there? I'm not trying to disable it, I just want to see which interface it is. So let's do this. So if I do a do show CDP neighbors, all right, so the only neighbor I see is the ISP off serial 000, which would mean that the other serial interface, serial 001 on router 1, that would have to be the serial interface that goes to router 2. And yep, serial 000 on router 2 is 192.168.1.2. So over here it's serial 001, and that link comes over to serial 002. Or I'm sorry, serial 000, which is 192.168.1.2. Okay. All right, well, there was quite a bit, 154 things to do in this skills integration challenge, and these are, again, some of my favorite activities to do in PacketTracer, because they pull together everything that you've worked on to this point and really require you to have a good understanding of what's going on. And I want to see this one more time. Advertise the network for each sub interface. and disable OSPF updates for each sub interface. All right, just making sure that they only wanted you, even though we're 100 out of 100, I wasn't sure if they wanted OSPF running between these two routers, but it's definitely not needed. So a lot of redundancy down here, right, in the configuration. We've got a ton of redundancy down here. And we've also got multiple paths out of the network, and so let's all PC should be able to ping the web PC. So the web PC is 64.104, and actually let's go ahead and let's confirm that. So we've got 64 ping 64.104.13.130, and let's see if we can get out here. So the request timed out, but then we've got a successful request. So let's see what happens if we do a trace RT. Let's see what way are we going here. Are we going out router 1 or are we going out router 2? So trace cert 64.104.13.130. And we're jumping to 192.168.10.1, which is router 1. And then router 1 is jumping to our internet cloud and then jumping over to the web server. So let's do something here real quick. Let's pull router 1 up and let's shut down that gig 00 interface hosting all of those sub interfaces. So we're going to go into global config mode, interface gig 00, and let's shut that down. Now let's pull PC 10A back up and run that trace route again. And let's see which way he decides to go now. So as you can see, the first hop timed out, or the first of the 3 packets timed out, the second packet timed out. So it looks like the request is timing out. And I'm trying to see if he's going to be smart enough to figure his way out of the environment here. Let's do control. Let's try ping now. So let's rerun that ping command, and let's see if we can ping the interface, or ping the IP 64.104.13.130. And it's timing out here. Let's see if it comes back up. And I wonder if it may have to clear the ARP cache, possibly on switch 1. Let's see if PC 20. Let's see what happens. So if I take PC 20, whoops, and let's ping with PC 20 to 64.104.13.130. All right, so it is working, right? So PC 20 figured out how to get out. So let's trace RT to 64.104.13.130. And so PC20A, when he comes into switch 3, he knows and figures out that he needs to go over here across this redundant link and then out to router 2, which is at 20.2, and then out to the internet and then over here. Let's pull PC10A up again and see if he's got it figured out yet or not. So he doesn't. He seems to be timing out. So we may need to wait for the ARP cache to time out. Let's check PC, or actually, yeah, let's try it on the reverse side. So if I say no shut, we'll bring that interface back up. And now let's come over here to PC10B, right? And we'll say ping 64.104.13.130. And he can ping with no problem. And so let's do a trace RT to see which way he's going out. So 64.104.13.130. So he hops up to 10.1, which is the sub interface on router 1. Is that correct? Yeah, he comes across over to router 1 and then out to the internet. And then let's check PC20B. And let's do a ping of 64.104.13.130. 104.13.130. And he can ping and get out, so we've got connectivity there. And then let's do a trace RT to see. Now he's going out via the sub interface on router 2, which is that .2 interface. So PC10B has decided to go out this path. 20B is going straight up to router 2 and then out. So let's do a trace again on this guy and make sure I saw the right thing. We did. So that traffic is going out to switch 1, and this traffic from PC20B is going out through switch 4 to 2. So who remembers what we did very early on that is allowing that to happen? And so if you scroll down here, you remember, right, layer 2 traffic engineering. What we did was on switch 1, VLAN 10, this is the primary root bridge in our domain, in our layer 2 domain for VLAN 10. So PC10B, he is in, let's make sure 10B is in VLAN 10. So 10A and 10B are both in VLAN 10. However, when traffic comes into switch 4, right, remember, this traffic is, it's being forwarded via layer 2 here, right? So it's coming into switch 4, and then it's a layer 2 forwarding decision. And switch 4, let's go ahead and take a quick peek at switch 4 here. Do a show spanning tree. So here's our VLAN 10, and switch 4 says, I'm not the bridge. He knows he's not the bridge because here's his address, or it would say this, this bridge root or this switch root. So here is the bridge ID, right? The MAC address of the root bridge. So let's take a look at what switch 1 has if I do a show spanning tree for VLAN 10, right? So here it is. This bridge is the root, and his MAC address is 23, ends in 2395. So if we come over here, there it is. So when the frame is received on switch 4 from PC10B, switch 4 looks at that and says VLAN 10. Who is the root bridge for VLAN 10? And then that layer 2 decision is made saying send him this way, right? Because for VLAN 10, this is your root bridge, okay? And that's why when PC20 trace routes out, he comes up to switch 2 and then to router 2 and up through the internet connection, because VLAN 20, when this frame comes in here and there's a layer 2 forwarding decision, switch 4 says, where is the root bridge? How do I get to the root bridge for VLAN 20? Remember that switch 2 for VLAN 20, switch 2 is the root bridge. So that traffic is going to be sent this way, right? And so let's go ahead and let's see if this is going to work. So here's what I'm going to do. I'm going to, let's clear that real quick, go back to the cursor. So if I come over here to switch 1 now, and remember, if we do a show run, and this is very important, you know, I know spanning tree is definitely not fun all the time, but when it comes to understanding spanning tree, it's critical. So you can see here, VLAN 20, we set the priority to 8192. But over on switch 2, we set the priority to 4096 for VLAN 20. So what would happen if here on switch 1, I were to say spanning tree, whoops, get in the global config, spanning tree VLAN 20, priority 0. Now what's going to happen? So let me come down to switch 4 now, and prior to this, switch 4 was going to say, for VLAN 20, my root port, which is the port closest to the root bridge, was port channel 2. was this guy right here, right? Because remember, switch 4 thought, or it was, switch 4 knew that switch 2 was the root. So he knew that the root port was going to be port channel 2, which is this guy right here. It runs between switch 2 and switch 4. So this is how he was forwarding the information, right? For VLAN 20 was using port channel 2. It was the root port, it was the forwarding state, and the cost was 3. Okay? And let me make sure I'm on switch. Yeah, we're on switch 4 here. So now that we've just changed the priority, right? The priority now on switch 1 is 0. So if I do a show spanning tree now, what should we see? And again, PacketTracer can be unpredictable, but let's check it out. So we take a look here at VLAN 20, and switch 4 still sees port channel 2 as the root port, even though here on switch 1, and let's confirm do show run, the priority here is lower. So this should be the root bridge, and it's very possible that we're just waiting on the timers, although I am not confident. We've done some spanning tree changes before in PacketTracer, and let's do show spanning tree VLAN 20. So it still thinks it's port channel 2, but it should think that it's this port channel right here is the best path, right? The root port should be here. And I think that that's going to be, if that's between switch 1 and 4, switch 1 and 4 is port channel 5. So PO5 should be that one, right? So let's take a look one more time. So PO5 right now is a designated port with a higher cost. So let me do this. Let me do write mem, and this will be last ditch effort here. So I've had success reloading, and then the switch will come back up and it'll give us the correct information. So let's double check this here, especially since it's not a real switch. It's kind of a fake switch. PacketTracer switch, so it reboots extremely fast. All right, so if I do a show spanning tree for VLAN 20. All right, port channel 2 is blocking. Port channel 5, great, fantastic. So, and I've had to reboot before in order to get these things when you make the spanning tree changes here. So as you can see right now, port channel 5, right, is the root port, and that's the forwarding port. Port channel 2 is blocking. And so let's see if this, nope, they're alternate ports, but they're blocking, right? So if we come back over here to PC20B now, and I trace route out again, and this may struggle here. Yeah, it looks like it might struggle. Can I see if I can still ping out? Whoops. Can I ping to the address? Request timed out, and let me do, let's do an ARP-A, I believe, or there's no ARP entries found. So yeah, it's still struggling to get out of the environment, but it should go out. Let's see, ping, let's pull the ping back up. Yeah, it should go out. It may be that PacketTracer's not letting us out because it's PacketTracer, but the key thing to note here is that's what that's what layer 2 traffic engineering is all about, especially with the spanning tree protocol, right? So that's our layer 2 traffic engineering. That frame comes in here, and switch 4 is going to look at its spanning tree topology to say, what is the next hop for me from a layer 2 perspective to get that frame from PC20B out here to this web server. And when we changed this to be the root bridge for VLAN 20, because now this is, whoops, this is now the root bridge for VLAN 20 up here, right? So now when switch 4 gets it, it's taking a look at the spanning tree, and it's going to say, that is my port that is the quickest port and the best port for me to get to the root bridge, right? So that is layer 2 traffic engineering. Okay? All right. So our score dropped 99 because we made some changes, but that's okay. So again, this has been PacketTracer activity 3.3.1.2. I hope that you have found this to be helpful and educational. And again, some really great stuff going on here. I love these Skills Integration Challenge packet tracers. All right, best of luck to you, and talk to you soon.